Module 1, Lesson 24, Percent and Rates per 100. So you might have noticed in this module we have chunks of learning. We kind of learned about ratios, and then we transitioned to learning about equivalent ratios. From equivalent ratios we have looked at rates, and now we're going to be looking at percents. And percents, before we have a stress moment, percents are just a special kind of ratio and rate. So no big deal, this will be fine. And you'll notice right here it says per 100. So unlike a lot of our other ratios where we have different two values, for example, to 100 or per 3, well, I should be careful here, per 5, to 5, or per 5. With percents, it's always to 100 or per 100. If we actually look at the word percent here, we have per, and cent means hundred, so per 100. All right, learning targets here. I don't have a learning target specifically written for percents because percents are a part to whole ratio right here. We work with equivalent ratios as we scale to 100 and down to 100, and we are looking at rates. So percents are actually layered through all of our different learning targets. All right, so I can today. So I can explain that percents are related to part to whole ratios. So a percent is a part to whole ratio, and rates where the whole is 100. And I showed this back on the first slide. So part to whole, we will have a 100, and we will have a rate of per 100. And we're going to represent percents with models so that we can visually see what's going on. And we want to connect percents to fractions out of 100 because once again we are looking at per 100s and out of 100s. So imagine that you're going shopping and you want to purchase an item for $100, but today it's 20% off. What does that mean? Well, it means that $20 out of every $100 will be subtracted from the total. We are going to take 20% away from the price, which would mean that we would need to find 20% of 100, which is $20. Now, thinking about how we could model this situation, oh, I didn't change that here. We'll actually look at a decimal grid with 100 parts in it. And no, it's not going to be a perfect picture there, but if we have 100 parts, then each dollar is one of those parts, is 100, and we could take those off. So how are percent problems related to the types of problems we've been working on that with ratios and rates? Well, percents are a specific rate. They are a per 100, and that means that they're a part to whole ratio with a to 100. So notice I keep stating the same thing over and over again. Percents are ratios and rates. They are ratios to 100. They are rates per 100. And this example here is simply getting us to think about things being in 100s. So we've got there's an online tool, and it doesn't work in Chrome. So I have to use Internet Explorer, so I'm going to switch the browser here. And this helps us visualize, and here's that grid I was talking about, a 10 by 10 grid. And I have set it up to show us 20%. So each of the 10 by 10 grids represents 100% because there are 100 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 by 10, there are 100 parts there. Well, that means that if we take 20 parts, we have 20 to 100. We have a ratio of 20 to 100, or 20 per 100 that I have shaded green here, and per 100 can be rewritten as 20%. So what we have on the model here is 20%. So 20% is green, but that also means then that there is 80% that is not green. A couple other things that this means. Each one of these 100th parts is 1%. If this all together is 100%, and it has been divided into 100 parts, then each one of the pieces is 1%. Now, another connection to make here is if this is 100 parts, and this is one part, it's 1/100th. So now we've connected it to fractions, and we can take 1/100th and we can also write it as a decimal. So percents connect to all kinds of things that we have already worked on. They connect to our ratios to 100. They connect to our rates per 100. They connect to the fractions that we have worked on, and they connect to the decimals that we have worked on. So percents are nothing to be intimidated by. We simply have to expand our thinking a little bit to include them. See if my finger here will touch things and adjust. Doesn't look like it's going to play nice. So you can see as we add each of these boxes, it goes up by 1%. As we take off boxes, each box represents 1%. Everything being 100%. There we go. All of it being 100%. Kind of a fun toy to play with, which is why I included the link. Notice that it doesn't work in Chrome. Chrome has blocked Java, so I use Internet Explorer for that. All right, so some exercises to play with these concepts to try and illustrate each of them as we go along here. Rob's Fruit Farm consists of 100 acres on which 3 different types of apples grow. On 25 acres, the farm grows Empire apples. Macintosh apples grow on 30% of the farm. So I want to emphasize that these are types of apples. The remainder of the farm grows Fuji apples. And our instruction is to shade in the grid to represent the portion of the farm each type of apple occupies. So we are going to show the part of the farm that grows Empire, the part that grows Macintosh, and the part that grows Fuji. And we're going to use a different color for each type of apple, and we are going to create a key to identify which color represents each type. Now, some things that I want to point out. First, we have 100 parts. The total farm is 100 parts, or 100%. So altogether, the whole is 100%, and that's an important concept. And now we can take a look at the parts, and we can see that 30% is the Macintosh. So I'm going to pick 30% here. Now I picked 30 parts. Stop and think for a second. Why did I pick 30 parts? Well, if all of this together is 100%, all of it is 100%, and I need 30%, that means each square is 1%. So I've got my Macintosh apples in blue. And I'm just going to scribble some blue there. And I can see that it's a ratio of 30 to 100. Now it says in the problem that the farm is 100 acres. This means that the 30% here is 30 acres. It also means that the 25 acres is going to be equal to 25%. Each one of these little squares is 1%, but they are also 1 acre. So I've got 10, 20, 1, 2, 3, 4, 5. So I've got 25 acres that are going to be the empire. I'll scribble that green there. And I've got 25 to 100. Now the last thing I have to figure out is the Fuji apples. Now the Fuji apples, it says, is the rest. The remainder of the farm is Fuji apples. So there are 100 acres, and I have already counted 30 and 25 acres, which means that I have used up 55 of the acres, which means that I should have 45 acres left. 10, 20, 30, 40, 1, 2, 3, 4, 5. So I have 45 acres, which is a ratio of 45 to 100, which also means that it is 45%. So I can make some statements here. I can say that 100% of the farm is 100 acres. I can say that 45 acres are Fuji apples, which is a ratio of 45 to 100 are Fuji apples, and I can say that that represents 45% of the farm. With the Macintosh, I can go through the same process, coming up with 30% of the farm is Macintosh, and then with the Empire, I can say that 25% of the farm is Empire apples. All right, exercise 2. The shaded portion of the grid represents the portion of granola bar remaining. What percent does each block of the granola bar represent? Well, let's see. They've already labeled it for us, and I see that each one of them represents 1/100th of the granola bar, which is, of course, the same as the decimal. And 1/100th is the same as 1%. 1 per 100, 1%. And the question is, what percent of the granola bar remains? Well, each of these is going to be 10. So I've got 10, 20, 30, 40, 50, 60, 70, 80. I have 80% remaining. And I'm going to connect that to the fraction 80/100ths, and I'm going to connect that to the fraction of 80/100ths, the decimal of 80/100ths, which I am also going to connect to 8/10ths. So what other ways can we represent this percent? Well, I just went through 3 of them. I could also put it as the ratio of 80 to 100. I could have 80/100ths. I could have 80/100ths. I could have 8/10ths, and I could have 8/10ths. All of these are different ways that we can represent this percent. I could go even further. I could take this 8/10ths here, and I could simplify it down to be 4/5. I could scale up and have 16/20ths. So all of this work that we have done with equivalent ratios can also be used with percents. We can scale up and we can scale down, following the same rules for scaling. All right, exercise 3A. For each figure shown, represent the gray shaded region as a percent of the whole figure. Write your answer as a decimal, fraction, and percent. We really need to connect firmly in our heads the connection between percents, fractions, and decimals. We need to see that they are talking about the same thing. So A is an interesting one. We have, the whole thing looks kind of shaded to me. So I'm going to focus on the dark gray section, and I'm going to say that 20% is the dark gray, and that is 20 hundredths, and that is 20 hundredths, and I'm also going to stretch and say that it is 2/10 or 2/10. If I wanted to look at the light gray, I could say that I have 80%, because there's 80, 10, 20, 30, 40, 50, 60, 70, 80. And I could have 80 hundredths, and I could have 80 hundredths, and I could have 8/10, and I could have 8/10. All right, taking a look at B, it says the gray shaded region. Once again, I've got a choice here. I've got kind of a light gray, I've got a dark gray, or I could put it all together and say gray. I'm going to work with just the light gray this time. So I am looking at this section here, and I see that it is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is 25%, 25 out of 100, and it is 25 hundredths. Now you'll notice that I didn't turn this one into tenths. Because the closest thing that I have to tenths is right here, 2/10 and 5 hundredths. I don't have an even number of tenths. On this first one, I had 2 complete tenths and nothing else. In here, I could make groups of 10, but I would have 5 left over. So I am not going to attempt to turn that into tenths. All right, picture C. Looks to me like I've got a lot of light gray here, and it's kind of mixed around. So I'm going to have to do just a little bit of work. I know that this will be 10, and this will be 10. And I know that this is 8, and this is 6, and this is 4. So 10, 8, 6, 4, and 10. The 6 and 4 together will make a 10, and the 10 and 10 makes 20. So I've got 20 plus 10 makes 30, 38. And I've got 2, 4, 6, 8, 10. So I'm counting 48 here. I hope that I'm counting it correctly. 48 out of 100, 48%, 48 hundredths, and 48 hundredths. Looking at the answer key, it looks like I did that one okay. And once again, I'm not going to try to write this one in tenths, because I've got 4/10 and then I've got 8 hundredths more. I don't have an even number of tenths. All right, so the ratios being modeled in each picture. Well, I've got the ratio of 20 to 100, and I've got the ratio of 80 to 100. I've got the ratio of 2 to 10 and the ratio of 8 to 10. And of course, we talked about we could do some scaling. I could have the ratio of 1 to 5, and I could have the ratio of 4 to 5 if I wanted to scale down. The 20 to 100 is the dark gray, and the 80 to 100 is the light gray. In picture B, I've got 25 to 100, and I could scale that down to be 5 to 20, so I've divided both of them by 5, and then I could divide again and have a ratio of 1 to 4 if I'm looking at the light gray. And the dark gray has the same amounts. If I look at the white section, I've got a different set of ratios. All right, looking at picture C here, I've got 48 to 100. And I could also say I've got 52 to 100, but that would be the white section. And our instructions were to focus on the gray section. But I do think it's important to understand that even though this represents the gray section at 48 to 100, we do have a ratio of 50 to 100 when we're talking about the white sections there. And I could scale this down quite a bit. I could scale, take out 2, and I would have 24 and 50, and I could take out 2 again and have 12 to 25. So I can do some scaling there. So there are lots of ratios in these pictures. But notice that all the ratios are equivalent to a per 100 or a to 100. So the ratios and the percentages, how are they related? Well, I hope that we're looking and saying that we've got a ratio of 20 to 100, which is 20%. And that is 20 hundredths. And that is 20 hundredths. Hopefully we're seeing that all of this stuff right here is saying the same thing out of 100. Even if I scale this down, this 20 hundredths to be 2/10, that is still equivalent to the 20 hundredths. So it may say per 10 or 210, but I could scale that up and be right out of 100 again. All right. So we've got an exercise here, and we are supposed to take this percentage, write it as a decimal, a fraction, and then create a model. Well, 6% is 6 hundredths, and it is 6 hundredths, and it's the ratio of 6 to 100, and I would draw my 10 by 10 model. And shade in 6 pieces. 1, 2, 3, 4, 5, 6. Now, I worry that I'm creating a misconception here that it's always about the shaded part. I could show 6% by shading everything but the 6. 1, 2, 3, 4, 5, 6. I could shade in everything else, and then the unshaded part is 6%. It's really important that we don't get into a bad habit of seeing only the shaded part, because the other part still exists. We have 6%, but we also have 94%. And when we combine it together, we have 100%. All right, so taking a look at this one, they give us 60%, and we need to come up with the decimal fraction ratio and the model. Well, 60% is 60 hundredths, and it's a fraction of 60 hundredths, and it's a ratio of 60 to 100. And part of my brain is saying I could write this as 6/10, 6/10, and 6 to 10 if I did some scaling. And so for a model, 1, 2, 3, 4, 5, 6, I have shaded in blue 60% or 6/10. Now that also means that the part over here, the remainder, is 40%. Altogether, 100%. 600%, so a little bit of stretching of the brain here. So 100% is one whole, 100 out of 100. And we've got 6 of those. So 600% is going to be the number 6. And the fraction is going to be 600 100ths. Because 100% is 100, and I have 6 of those. And the ratio is 600 to 100. And here is what it looks like as a model. Each of these is 100%. So if I want to have 600%, I am going to need 6 of them. So all together I have 600%. And that's kind of a mind-blowing thing for some students to stop and think about that. But 100% is 100 over 100. So if I have 600%, I'm going to have to repeat that 6 times. And if we add them together, The denominator is going to be out of hundredths, but there is 600 in the numerator. 600 100ths, which is the number 6. Kind of fun, kind of cool to look at. All right, so 32%. And I really like doing the fraction first. My brain just really works that way because I instantly go to hundredths and want to write 100. Ratio 32 to 100. For a model, I'll need 32 pieces, 10, 20, 30, and 2 more. So I have 32 hundredths that I have shaded. Now, once again, I want to draw attention to, there's also the rest over here. I have 68% that is not shaded. I have 68 hundredths over here. Together, if I combine them, the 32% and the 68%, I have 100%. All right, 55 hundredths. This time they give me the decimal, and I read it as 55 hundredths. And so I'm going to write 55% and 55 hundredths, and a ratio of 55 to 100. And I'm going to create a model here, and I need 55. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've got 55% here. And again, I want to draw attention to this part does still exist. It's the 45% because together it is 100%. So if I know this is 55, I can do 100, subtract 55, and be left with 45. All right, so this next one gets a little bit tricky here. They gave us tenths, 9 tenths. If I wanted to turn this into a percent, I could scale this up to hundredths, multiply by 10, multiply by 10, and I would have 90 100ths. And now I have 90 hundredths, and I have 90%, and I have 90 to 100. And model-wise, 90%. Which means that I have 10% hanging out over here. All right, so this next one, they give us the model and we have to work with it. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and I've got 1, 2, 3, 4, 5, 6, 7 of them shaded. I'm actually going to split this and do this problem 2 ways. I could say that I have 7 tenths that are shaded, which will be 70 hundredths, scale up. And I've got 70 hundredths and 70%, which is 70 to 100. But I can also, in this model, because it's not always about the shaded area, I could look at the unshaded area, which I could say is 3 tenths, which would be 30 hundredths. I've scaled up, multiplying by 10. And I've got 30 hundredths, and I've got 30%, and I've got 30 to 100. All right, Mr. Brown shares with the class that 70% of the students got an A on the English vocab quiz. If Mr. Brown has 100 students, create a model to show how many of the students received an A on the quiz. So I am looking for 70%. 1, 2, 3, 4, 5, 6, 7. So what fraction? Well, there are 100 parts there, and 70 of them are an A. And I can represent that as a decimal as 70 hundredths or 7 tenths. The decimal, the fraction, the percent are all talking about the same thing. 70% is equal to 70 hundredths, which is equal to 70 hundredths. This is all the same thing. Marty owns a lawn mowing service. His company, which consists of 3 employees, has 100 lawns to mow this week. Use the 10 by 10 grid to model how the work could have been distributed between the 3 employees. So this is a problem where you get to make some decisions. There are 100 lawns. They all had to be mowed. And the question is, how are they going to be distributed? Well, I think I can take employee 1 here, and I'm just going to give a straight 30% to employee 1. And I'm going to say that employee 2 has worked very hard. And I've got 10, 20, 30, 40. 1, 2, 3, 4, 5. So 45, 50, 55. So 55% and 55 hundredths and 55 hundredths. And that leaves for employee 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've got 15%, 15 hundredths, and 15 hundredths. Now, some people might look and say, oh, employee 3 is this horrible employee. Something to consider here is even though there are 100 lawns, we don't know if the lawns are the same size. Maybe employee 3, maybe their lawns were 5 times bigger than the other employees. So even though we know the percentage of the 100 lawns, we still don't know the size of the lawns. All right, so lesson summary. 1% is the number 100th, and we write it as 1%. Percentages can be used as rates per 100. 30% of a quantity means 30 hundredths times the quantity. So 30% of 5 is 30 hundredths of 5, or 30 hundredths times 5. We can model percents using a 10 by 10 grid, 100 parts. Each square in the grid represents 1% or 100th. All right, so hopefully at this point you are feeling like you can explain that percents are related to part-to-whole ratios and rates where the whole is 100. And hopefully you're feeling like you can do some basic modeling with percents, and that you can write a percent as a fraction over 100 or a decimal to the hundredths place. And hopefully also you are seeing that percents fit in with all of the ratio and rate information that we have worked on. So this concludes Module 1, Lesson 24. If you've got questions, make sure you talk to your teacher and complete your problem set.